We'll be exploring the RidgeClassifier, a machine learning algorithm, and its crucial alpha hyperparameter. Think of RidgeClassifier as a tool that helps us classify data points into different categories. The alpha parameter acts like a dial, controlling how much the algorithm prioritizes simplicity over accuracy. This problem focuses on using RidgeClassifier for multi-class classification. That means we're classifying data into more than two categories. The dataset is also described as high-dimensional, many features, and potentially having multicollinearity. Features are related. This is important because it highlights the need for regularization, and that's where alpha comes in. I'm presenting you with 4 statements about alpha's behavior, and you'll need to decide which are true. We'll analyze each one carefully. It's all about understanding how alpha affects the model. This statement says that increasing alpha makes the model simpler, higher bias, and less sensitive to the specifics of the training data, lower variance. I'll help you understand why this is often true. This is about the type of regularization. The statement claims alpha controls L1 regularization, also known as lasso. This is a common misconception we will clarify, determining if it's correct or incorrect. This statement claims setting alpha to 0 removes the regularization and leads to a standard logistic regression model. I'll explain what happens when we set alpha to 0 and how it impacts our model. This statement proposes that increasing alpha leads to bigger weights in the model. This might sound intuitive, but we will check whether this assumption is valid or not. This is the title of the problem. We'll be focusing on the alpha hyperparameter within the scikit-learn's *RidgeClassifier algorithm. It's a crucial part of understanding how this algorithm works. Increasing alpha makes the model simpler by penalizing large coefficients. This means it fits the training data less closely, higher bias, but this also makes it less sensitive to the quirks of that specific data, lower variance, leading to better generalization to new data. Think of it like this: a simple model is like a generalist. It's not super specialized for one thing, but it's pretty good across the board. When alpha is 0, the penalty term disappears entirely. This means the *RidgeClassifier* becomes just a standard multinomial logistic regression, no regularization involved. This is incorrect. Alpha controls the strength of L2 regularization, also known as ridge regression. L1 regularization is a different technique called lasso that uses the sum of absolute values of coefficients, not the sum of squares. This is wrong. A larger alpha increases the penalty, pushing the coefficient values closer to 0, which causes smaller magnitudes of weights and helps the model avoid overfitting, thus improving its robustness. Think of it as a gentle nudge towards simplicity. This instruction tells us to choose all the statements that are correct about the effect of *alpha on the *RidgeClassifier*. We're diving into the scikit-learn RidgeClassifier, a powerful tool for classification. A key part of this is the ALPHA hyperparameter, which controls the strength of regularization. I'll explain how it works. This is a multiple-choice question testing your understanding of the ALPHA hyperparameter in the RidgeClassifier. Get ready to put your knowledge to the test. The scenario sets the stage. You're using the RidgeClassifier for a multi-class classification problem. This means we're dealing with more than 2 classes, like classifying images into categories, and there might be many features in our data which are correlated. It's important to use RidgeClassifier to handle high dimensionality and multicollinearity. This statement explores how increasing the ALPHA value affects the model's bias and variance. Remember, bias refers to how well a model fits the overall trends in data, while variance refers to how much the model changes with different datasets. This statement tests your understanding of what ALPHA actually controls. L1 regularization, lasso, uses a penalty term based on the sum of the absolute values of model coefficients. It's different from L2 regularization. This statement explores what happens when the regularization is completely turned off. No penalty, no constraints on the model's coefficients. This explores the effect of a large ALPHA on the model's coefficients, the learned weights for each feature. We need to consider if a large ALPHA makes them bigger or smaller. This simply indicates the start of the multiple choice options, A, B, C, and D. The options are used to test the understanding of the effect of alpha. This reinforces that the whole quiz centers around the RidgeClassifier algorithm and its hyperparameter, ALPHA. It's the core concept. We're diving into the RidgeClassifier, a powerful tool in scikit-learn for tackling classification problems. A key aspect is understanding its alpha hyperparameter, which governs how strongly it applies regularization. Think of it like a control knob that fine-tunes the model's behavior. The ALPHA parameter is the heart of L2 regularization in RidgeClassifier. It directly scales how much we penalize large coefficient values in our model, influencing how much the model simplifies itself to avoid overfitting. A higher ALPHA means a stronger penalty, forcing coefficients towards zero. I visualize it as a lever. You pull it, increase ALPHA, the coefficients shrink towards zero, and the model becomes simpler. L2 regularization, also known as ridge regression, aims to prevent overfitting by adding a penalty term to the model's loss function. This penalty is proportional to the sum of the asterisk squares of the model's coefficients. Alpha directly controls the strength of this penalty. Imagine fitting a curve to data points. A high ALPHA forces a simpler, smoother curve, higher bias, lower variance, while a low ALPHA lets the curve wiggle more closely to the points, lower bias, higher variance. This is a multiple-choice quiz question focusing on the effects of the alpha hyperparameter in the RidgeClassifier model. We're diving into the scikit-learn's RidgeClassifier, a powerful tool for multiclass classification. A key part is the alpha hyperparameter, which controls the strength of regularization. We will see how alpha affects the model. This is a multiple-choice question testing your understanding of alpha in RidgeClassifier. Get ready to test your knowledge. I'm presenting you with multiple statements related to the alpha hyperparameter in RidgeClassifier, and I want you to pick the correct ones. It's a test of your understanding of how this parameter works. Increasing alpha makes the model simpler, higher bias, and less sensitive to fluctuations in the training data, lower variance. I find this statement correct. Nope. Alpha controls L2 regularization, not L1. L1 regularization, lasso, uses the sum of absolute values of the coefficients. This statement is false. When you set alpha to 0, you completely remove the regularization penalty. Your model becomes a standard multinomial logistic regression model. Correct statement. Incorrect. A larger alpha actually shrinks the coefficients towards 0, resulting in smaller weights. This is the specific type of classification algorithm we're focusing on. It uses L2 regularization to prevent overfitting. This is the key hyperparameter we're discussing. It controls how strongly the model is regularized. A higher alpha means stronger regularization. This is the final result of the RidgeClassifier. We are not particularly focusing on the output of the classifier. I'm focusing on the RidgeClassifier, a machine learning algorithm. Its core is understanding how the ALPHA hyperparameter influences its behavior. Alpha tunes the strength of regularization, specifically L2 regularization. I'm evaluating several statements to determine their accuracy concerning ALPHA's role in a RidgeClassifier. Think of it like a multiple-choice quiz on the subject. This statement claims that increasing ALPHA leads to higher bias and lower variance. I'll check if that's true based on my understanding of RidgeClassifier and regularization. Here, we're looking at whether ALPHA governs L1 regularization. I need to remember the difference between L1 and L2 regularization to judge this claim's validity. This statement proposes that setting ALPHA to 0 transforms the RidgeClassifier into a standard logistic regression model. I must verify if removing regularization leads to this transformation. This statement suggests that increasing ALPHA results in larger feature weights. This is about how the model's parameters are affected by the regularization strength. This is the algorithm at the heart of the problem. I'm dealing with a RidgeClassifier, a type of linear model. These are the independent variables that the model uses to make predictions. Think of them as the input characteristics we feed into the model. These are the dependent variables, or what the model aims to predict. These are the output values we're trying to learn. This hyperparameter controls the strength of L2 regularization in the RidgeClassifier. It's a key tuning parameter. A larger value means stronger regularization, pushing coefficients towards zero. This statement simply introduces the topic. We'll be focusing on the alpha hyperparameter within the scikit-learn's RidgeClassifier. Get ready to learn. This tells us that we're facing a multiple-choice question about the behavior of alpha. I'll guide you through the options one by one. This is the core question. We need to identify which statements correctly describe how the alpha parameter affects the RidgeClassifier model. It's important to note that more than one answer might be correct. This statement is incorrect. I want to emphasize that ALPHA in RidgeClassifier controls L2 regularization, not L1. L1 regularization uses the sum of the absolute values of the model's coefficients, also known as lasso regression, while L2 regularization, used by RidgeClassifier uses the sum of the squares of the coefficients. This statement is also incorrect. A larger alpha value actually strengthens the penalty applied to the sum of squares of the coefficients, forcing those coefficients toward zero. Therefore, a larger alpha leads to smaller weights, not larger ones. Remember, this is the key to understanding the effect of regularization. This statement is correct. When alpha is zero, the regularization term disappears. This means the model behaves exactly like a standard multinomial logistic regression model. No regularization is applied. This statement is also correct. Increasing alpha increases the strength of the L2 penalty, which simplifies the model, higher bias, but makes it less sensitive to fluctuations in the training data, lower variance. I see this as a trade-off. We're prioritizing model simplicity and stability over perfect fitting to the training data. This simply indicates that we've reached the multiple choice options.